Okay, this is Lauren, Physics 350, homework 4, problem number 2. Part A is find a formula for the electrostatic potential everywhere along the symmetry axis of a charged ring. And we're supposed to use Griffith's equation 230 to do this. So this is kind of what it's going to look like. This is the equation Griffith's 230 right here. So if we look at this ring, we can see that the r vector is in only the z direction. And so then we have r is z hat, and then we have the r prime vector is only in the r hat direction, so we get this, and d vector is r minus r prime, so then we get this. We need to rewrite the magnitude of d, so we use the Pythagorean theorem, and we can do this because theta is equal to 90 degrees. So we get d is the square root of z squared, which is this, and plus r prime squared, which is this part here. Definition of dl prime is r prime sine theta prime d phi prime, but since theta is 90 degrees, then sine theta prime goes to 1. So we're left with just r prime d phi prime. And then if we plug this in to this equation up here, we get this right here. We can pull the lambda out because it's uniform. This is up there. So then we end up with this. So then if we have a full ring, then we want to take this and we want to integrate from 0 to 2 pi. Everything comes out of the integral except for d phi prime. So then we're left with this. R prime is equal to a because that was the radius that we were given for the ring. And so then we end up with this as our final answer. The next part I'm going to do is showing the behavior as z approaches infinity. So here we have the equation that we got from up here from part A, and so as z goes to infinity, z squared plus a squared is approximately just z squared. Square root of z squared is z, and multiply that by 2 times epsilon. It's basically just infinity still. A finite value lambda a divided by infinity is always 0, so the limit of v as z approaches 0 is 0. And then if we are to plot this, which the question also asks us to do, we get something that looks like this, and we can see that as z gets closer to 0, we're undefined, and then as we found from part C, as z approaches infinity, the limit of v is 0.